Hello grade 12. We are back with the second part of activity 1 from lesson 5. Now before we go on, there is something I mentioned but I completely forgot to write here. You can see that the answer is not well. You multiply by -1, so the answer must be negative. So please fix that one, okay? I'm very sorry. I mentioned in the video, but I forgot to put the minus at the front. All right, so let's quickly go. There is the question: a block of 85 kilograms starts moving from rest under the action of a force of magnitude 240 Newton that forms an angle of 20 degrees with the horizontal. The coefficient of kinetic friction is 0,2 and the block moves a distance of 8 meters. Calculate the work done by the pulling force. Remember last time we did the drawing, we write the data and we draw the free body diagram including the components. Remember, the components are not part of the free body diagram, but it's helpful to show it so you know what forces are on the x-axis and which forces are on the y-axis. Here is the calculation of the work done by the applied force. It's 1804,21, and then calculate the work done by the frictional force. Remember, there was a little bit more work to do to answer that one. The work done by frictional force is equal to frictional force multiplied by displacement multiplied by the cosine of theta. Theta is 180. We didn't have frictional force, and then we did calculate it. And then the final answer for the work done by the frictional force was a negative 1,201,47. Now, sorry. Before we continue, remember the meaning of the minus. It is not direction. It means that energy is being taken away from the system by the frictional force. All right, so let's continue with the next question. The next question is 1.3, right? So let's answer question 1.3. Question 1.3 said calculate the net work done on the block by the force. Now remember, net work is the algebraic addition of the work done by all the forces. Okay, so 1.3, they're looking for net work. Now, if we go to the free body diagram, the forces that act there are the applied force. Let me just probably do this so we can see. Okay, the forces are the applied force, the normal force, the frictional force, and the gravitational force. We have in 4 forces. These are the components, so you don't have to include it into the forces. The component is just the breaking down of the applied force. So we're going to calculate the work done by each of them. Now we have already calculated, we already have the work done by the applied force, and we have the work done by the frictional force. All right, so the net work is equal to the work done by the applied force, which is calculated, plus the work done by the frictional force, which is calculated, plus the work done, work done by the normal force, plus the work done by the gravitational force. Okay, let's take all this and move it a little bit down. Let's move it here, right? So there we are. Okay, so these forces, this work done by these forces is calculated. Let's quickly see the normal and the gravitational force. So the work done by normal is equal to normal multiplied by displacement multiplied by the cosine of theta. Now, what is theta? If you go to the free body diagram, you can see that the normal is straight up, vertical, and the displacement is horizontal. The angle between the normal and the displacement is 90 degrees. It's 90 degrees. So I'm going to write here theta is equal to 90 degrees. And remember that cosine of 90 degrees is equal to 0. Therefore, the work done by normal force is equal to 0 joules. Okay? Now, if you go to the work done by gravitational force is equal to gravitational force displacement cosine of theta. And in this case, theta is also 90 degrees. Cos 90 degrees is equal to 0. Therefore, the work done by the gravitational force is also 0 joules. Right? So now we can calculate the work done by the net force. Work done by net force is equal to work done by the applied force. Let's go back to the calculation. Is 1804.21. So let's substitute that one into here. It is 1804.21. The frictional force. Work done by frictional force is minus 1201.47. 1000 is negative. 1201.47. The work done by normal is 0 and the work done by gravitational force is 0, so I'm not going to substitute. So the work done by the net force is equal to, let's use our calculator. Here we are, we have 1804.21 minus 1201.47. The 7 is there. And that gives me 602.74. 602.74 joules. This is the work done by the net force question. So let's go now to question 1.4. In question 1.4, they ask to, using the work energy theorem, calculate, the word is missing there, calculate the speed of the block when it has traveled 8 meters. Right, so let's go quickly to answer that one. 1.4. Work energy theorem. Let's recall what does the work energy theorem state. It states that the work done by the net force, in other words, net work, is equal to the change in kinetic energy. Right? Net work was done in the previous question. It was calculated in the previous question. Here you can see it. So the only thing we don't have is a change in kinetic energy. Remember, change is final minus initial. So let's break this equation, this formula, a little bit further, this theorem. So we have that work done by the net force is equal to final kinetic energy minus initial kinetic energy. And from previous grade, let me not mention the grade because it might be different in other places. Kinetic energy is equal to half the product of the mass minus the speed times the speed to the power 2. So that is what we have to substitute here in the theorem. We have that net work is equal to half mass multiplied by final speed square minus half mass initial speed square. Alright, and now we can substitute all the numerical values into this equation. So net work is right there, is 602.74 is equal to half the mass of the block. Let's quickly go to the data just for you to see. It's 85 kilograms. So multiply by the 85 kilograms multiplied by the final speed square minus half multiplied by 85 multiplied by 85 multiplied by the initial speed. Remember that we spoke about this one at the beginning. The object start moving from rest, and therefore the initial speed is 0. So here will be 85 multiplied by 0 to the power 2, and therefore everything here is 0. Right? So this is what we have. All is just rearrange the formula and do the calculation. Alright, so we have that this 2 is divided here, you move to the other side, multiplying, so you have a 2 times, let's use the bracket been using up until now, 2 is 2 multiplied by 602,74, and the 85 come down here, divided by 85 equal to final speed square. All right. Now, if you use the square root on both sides, then the calculations, let's do it quickly now. Let's just show you the square root. You have to get the square root on both sides. This is mathematics on both sides. So the square root cancel with the square, and then final speed is equal to the square root of 2 times 602,74 divided by 85. So let's go to our calculator here, so you can see the calculation. Okay, the calculation is a square root of 2 times 602,74 divided by 85. That is equal to 3,7659. So we're going to round off to 2 decimal places, 3,77. That is the answer for the final speed. There we go. Okay, so this is the answer for the final speed. Question 1.4 is also done. Let's go to question 1.5, and this is the last question. Say, apply Newton's second law of motion to calculate the magnitude of the acceleration of the block. If you come here to the free body diagram, remember the object is moving on the horizontal, so we are going to only use the x-axis. Now, what forces do you see in the free body diagram on the x-axis? We have the component. Let me just mark here quickly. We have the component of the force in the x, and we have the frictional force as well. One is pointing in one direction, and the frictional force is pointing in the opposite direction. Okay, so let's go back to 1.5. So question 1.5, they say Newton's second law. Use Newton's second law. Remember Newton's second law. Now here we're going to work in the x-axis. Let's going to select that direction as positive. Okay, now they say use Newton's second law, and therefore I'm going to start with Newton's second law. Is equal, and net force is equal to the product of the mass and the acceleration of the object. Right? Now, what forces are acting in the x-axis? Remember, that was the applied force in x and the frictional force, which is pointing in opposite direction, therefore is negative. Frictional force is equal to the product of mass and acceleration. Remember, here, the applied force in x is equal to the product of the applied force multiplied by the cosine of 20 degrees. Right? This one is in the free body diagram. So we are going to write that one in the equation. We have here applied force multiplied by the cosine of 20 degrees minus frictional force is equal to the product of mass and acceleration. Now, we can do the substitution. We have everything. The frictional force was calculated in previous sub-questions. Okay, so let's substitute. The acceleration, the applied force, is 240 multiplied by the cosine of 20 degrees minus frictional force, which was calculated. Let's just see it, so you can notice here when 1.2 we calculate the frictional force. You can see it right here. Okay, 150,184. So let's go there. Minus 150,184 is equal to the mass, which is 85 multiplied by the acceleration. Okay, these calculations can be done. It's very, very simple. Let's do the whole calculation so you can see it. Here we are. So we have 240 cos of 20 degrees. That is equal to 225,526, and there is more numbers. Now that one is minus 150,184. We have 75,34. Let me show you here. This is what we done just now. This calculation. Now the 85 is moving to divide. Okay, so we divide both sides by 85, and that is what we're going to substitute in the calculator. All that is divided by 85. The final answer is 0,8863. So we're going to round off to two decimal places, will be 0,89. Acceleration is equal to 0,89 meters per second squared. That is the answer. The problem is being solved. You can now look at the problem, and you can write any comment if there is a suggestion or something is not clear. Okay, thank you very much. I hope you understand the question.